I told you the meaning of the centroid of a triangle. If you remember what I had told you in your class 9, that a centroid of a triangle, given any triangle, let me erase this better. Given any triangle, okay, if I give you any triangle ABC,
Good
and
morning, sir.
morning. Now, if you take the midpoints of the sides of the triangle, each side you take the midpoint. Okay, so BC you take the midpoint, AB you take the midpoint, and AC also you take the midpoint. Let us call the midpoint of AB as P. Let us call the midpoint of BC as Q, and let us call the midpoint of AC as R. And you join this all the three midpoint. You join not the midpoints. In fact, what you do is from a vertex of a triangle, say vertex A, you draw a line and you join the midpoint of the opposite vertex. This straight line. This straight line becomes your median of the triangle. This straight line is called the median of the triangle. So therefore, not one median, but in fact there are three medians that are possible in case of a triangle. You can have a median like this, and you can also have a median like this. Okay, so there are three medians possible in the case of a triangle. So you have these two to be equal, these two to be equal, you have these two equal, and you have these two equal. Okay, all these are equal, and we say that AQ, BR, and CP are the medians. This line segment, all these line segments are the medians of triangle ABC. Okay, so this was the definition of median. Now, definition of centroid. The point of intersection of the medians, or the point of concurrence of the medians of a triangle, is called the centroid of the triangle. So you have your median AQ, BR, and CP. You see that all of them meet at a point. Let us call this point M. Then M is called the centroid. M is called the centroid of triangle ABC. Okay, so I hope that the concept of centroid is clear. Now, once the concept of centroid is clear, I would like to mention a theorem which I'll be using in the in this. The theorem is, which I've written here. I think yes, this one. Yes. Okay. So in statement form, the theorem can be stated as a centroid, or the centroid of a triangle divides divides each median in the ratio in the ratio 2:1. The centroid divides each median in the ratio 2:1. What does this mean? See that in this figure, I have M as my centroid. Then according to this theorem, here we have two parts, and here I have one part. So that this ratio AM is to MQ is 2:1. Similarly, this length is two parts, this length is one part, so that CM is to MP is equal to 2:1. Okay. Also, this length is two parts and this length is one part, so that we can write BM is to MR is equal to 2:1. This is what this theorem states. We shall be using this theorem. This is a basic geometry theorem, okay, which we shall be using to find out the coordinates of the centroid. So let us now find out the coordinates of the centroid. So according to this here, you can see this as a theorem also, that the coordinates of the vertices, the coordinates of the centroid of a triangle ABC whose vertices are AX1Y1, BX2Y2, and CX3Y3 is X1 plus X2 plus X3 divided by 3, Y1 plus Y2 plus Y3 divided by 3. Now remember, we shall be using this result. Okay, mostly we shall be using this result. You need to remember the formula, that the coordinates of the centroid of a triangle having vertices x1 y1 x2 y2 and x3 y3 is this. Now the proof I am discussing only as an application of the section formula. The application may come separately and in not only this form but some other form. So let us draw the triangle first. So you have, let us call this as x1 y1. Let us call
Excuse
this
me,
as,
sir.
yes.
So we cannot take k is to 1 in place of 2 is to 1.
Why will you take case to 1? When the proof, when you know the truth, then why hide from it, right? What do they
So
call you at
means
home? In fact, whatever. Suppose you have a certain name, say X at home, okay, and if I know your real name, Apurva, I prefer to call you by your real name, isn't it? So why should I call you by some other name, X? When I know the value of this ratio, that it is 2:1, it cannot be any other value apart from 2:1, then why should I take k:1? Understood? If I did not know the ratio, then I would have taken k:1, no problem. You understood?
yes, sir.
Let us take the midpoints, say p, q, and r, and we draw the medians. I've taken the coordinates of the vertices as x1, y1, x2, y2, and x3, y3. This is one median. This is another median. And this is your third median. Okay. And let us call this point M. Okay. So M is our centroid, and Q is the midpoint of BC, P is the midpoint of AB, and R is the midpoint of AC. Let us be very clear about this. Okay. So now I want to find out the coordinates of M here. So what I want to do here is that first I would like to find out the coordinates of Q. So what are the coordinates of Q? Since Q is the midpoint of BC, therefore coordinates of Q will be what? From the midpoint formula, x2 plus x3 by 2, y2 plus y3 by 2. Am I right? Coordinates of Q?
Yes, sir.
Because Q is the midpoint of BC. Therefore, I'll use the midpoint formula to get the coordinates of Q. Now, look at the line AQ. Look at the median AQ. You know the coordinates of A. You know the coordinates of Q. Here, you know them, right? Also, what you know is that AM is to MQ from this theorem, the theorem that I just stated here. Okay, that 2 is to 1, and which Apurva wanted to take K is to 1. Okay, so here I have AM is to MQ is equal to 2 is to 1. So that means this here I have two parts, and here I have one part. I know this for a fact that whatever, if I have a centroid, then definitely this uh, here I will have two parts, and here I will have one part. That is an established truth. That is an established fact. Okay, so I will use this fact. So AM is to MQ, I know is 2 is to 1. Now from section formula, if you consider this line straight line, if you consider this straight line AQ, A, X1, Y1, and you have say this point as your um, Q. Those coordinates I have x2 plus x3 by 2, comma y2 plus y3 by 2. So you have 2 points A and Q, these two, and in between you have your median here, M. You have a median. Can you find out the coordinates of M if I give you that two parts lie here and one part lies here? Can you find this by section formula? Yes, you can, isn't it? Right? Therefore, what should be the coordinates of M? Coordinates of M should be, this one is your x1, y1, and this one we'll take as our x2, y2, right? So this will be, and this is your M, and this is your N. So M here is 1, and N here is, M here is 2, N here is 1. So according to your section formula, we have M x2. And what is x2? X2 is this. So x2 plus x3 by 2 plus N. What is my N here? N here is 1. X1 is x1. X1 is this divided by M plus N. 2 plus 1. And y coordinate will be M y2. M here is 2. Y2 here is this one. plus n y1. N here is 1 and y1 here is this, divided by m plus n. Okay, so this will give our coordinates. Now we simplify this. M, what happens? These two cancel. Here these two cancel. You simply get x2 plus x3 because 2 cancel, and 1 into x1 is your x1 divided by 3. And here you have y2 plus y3 plus y1 divided by 3, which is the same as x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Okay, so this is how we derive the from section formula the coordinates of the centroid of a triangle. Now this theorem itself may not be given, but it can be given in some other form. Okay, that is why the understanding of the way of calculating this is important. Okay, so let us do one application of this formula. Find the coordinates of the centroid of triangle whose vertices are. So here we have example 1. What are the vertices given? A minus 1, 3, B 1 minus 1, and C 5, 1. These are the vertices given. Okay, we want to find out the coordinates of the centroid. So we take this as our x1, y1, this as our x2, y2, and this as our x3, y3. And therefore, coordinates of the centroid of triangle ABC is, add up the x coordinates, x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3. So this is 5 by 3 because 1 and minus 1 they cancel each other. Similarly here they cancel each other, so you simply get 3 by 3. So which is 5 by 3 comma 1. This is your coordinate of the centroid. So this was easy enough, I think. Any questions here?
No, sir.
Let us do a second example, another application of this. The vertices of a triangle are, let us write what are the given vertices. A, given vertices or given, minus 5, 3, B, P, minus 1, and C, 6Q. Okay, these are the vertices of the triangle. You need to find out the values of P and Q, given that the centroid of the triangle ABC is the point 1, 1. So what are the coordinates of the centroid? This is also given to you. 1 minus 1. You need to find out the values of P and Q. So what you do here is, first you take these three coordinates and you find out the coordinates of the centroid. The coordinates of the centroid of triangle ABC is minus 5. You add up the x coordinate. This is your x1, y1. This is your x2, y2. And this is your x3, y3. Add up the x coordinates. x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So this, simplify this, you get p plus 1 by 3, and here you get q plus 2 by 3. Okay, you get the coordinates of the centroid in terms of P and Q as this. But what is the coordinates of the centroid given here? 1 minus 1. So therefore, P plus 1 by 3, Q plus 2 by 3 must be equal to 1 minus 1. And now you get two equations from which you can solve for P and Q. So I have P equal to 2 and Q equal to minus 5. So I've solved for P and Q, and these were the required values. This is what they had asked you to find. Find the values of P and Q. Any questions till this point?
No, sir.
So let us see some applications now of in terms of solving problems. Yesterday I sent you some notes on this chapter.
Yes, sir,
These notes I
please.
sent. What please? Please for what? Okay.
For the notes.
Please or thank you.
Sir, why will I say thank you?
And why then why please?
So that you send. You're asking, no, that will I send? So I'm telling
I
yes,
have already
please.
sent, Apurva. I have already sent. Okay.
Sir, I have these notes I've written also.
Hmm. Fine. Section formula. These are the problems taken from your exercises. In fact, whatever problems, the example that I discussed earlier, also they are also taken from your exercises. Okay. And whatever problem, the important problems that were left, the variations, these have been, this I will discuss here. So let us discuss the first problem here. The line segment joining the points 3, minus 4 and 1, 2 is trisected at the points P and Q. Now what do you mean by trisected? Bisected and trisected. Bisected, trisected.
Sir, I'll say
Yes. Tell me.
Trisected meaning divided into 3 equal parts.
3 equal parts. Yes. Bisected means divided into 2 equal parts. In English, you know, bi means 2 and tri means 3. So therefore, when I say bisected, what I mean is that divided into 2 equal parts. I have a line segment here, and I have my point E here, and I have my point B here. If I say bisected, I mean this line segment has been divided into 2 equal parts. Okay, that is P is the midpoint of AB when I say bisected. But when I say trisected, I mean that the line segment has been divided into 3 equal parts. The same line segment AB AB has been divided into 3 equal parts. So this is one point, say P, and this is the another point, say Q, such that these three must be equal. This is what your trisected means. Okay, so here it is given that the line segment joining the point 3, minus 4, let us call this point 3, minus 4, and 1, 2. So let us call this point 1, 2. This line segment joining these 2 points is trisected at the points P and Q. So P and Q divide this line equally into 3 parts. If the coordinates of P and Q are, so coordinates of P is given to be small p minus 2, and coordinates of Q is given to be 5 by 3 comma Q. Find the values of P and Q. Okay. Now if this straight line, we start by saying, let this length AP be K. This PQ be K and this QB be K. So we start by saying, let AP equal to PQ equal to QB equal to K. Because all these are equal in length, we can take them to be K. So therefore, what should be my AQ? What should be, let's say P, let's consider P first. What should be my A? So AP is K. Okay. And what is PB? What is PB? PB is K plus K. Let's say 2K. Right or wrong? This length is K. So what is this length? What is this length?
2K.
2K. That is what I have written. AP is K, PB is 2K. Okay. So what is the ratio of these two? Therefore, AP by PB is K by 2K, which is half. So that means AP is to PB. What is this ratio? AP is to PB is 1 is to 2. That means one part lies here and two parts lie here. Right? This is what it means. Fine. So now we proceed to find out the coordinates. We know the ratio. We know A and B. We know A and B, the extreme points. We also know the ratio. AP, that P divides AB in the ratio 2 is to 1. We know that P divides AB in the ratio 2 is to 1. 1 is to 2. 1 is to 2. Okay. So now we proceed to find out the coordinates of P by section formula. Therefore, coordinates of P. What are the coordinates of P? mx2 plus nx1 by m plus n. my2 plus ny1 by m plus n. Now what are x1 and y1 here? So this one is my x1, y1, and this one is my x2, y2. And AP, this length, this is my m, which is equal to 1. And what about this length? Here n is equal to 1. 2, sorry, 2 parts. N is equal to 2 parts. M is equal to 1 part, right? So we know the ratio also, we know the values of m and n, we know the value of x1, y1, x2, y2. Let us write down. X1 is 3, y1 is minus 4, x2 is 1, y2 is 2, m is 1, and n is 2. Now we shall use section formula. We just put it in the section formula, in fact. M x2 plus n x1 divided by m plus n. M y2 plus n y1 by m plus n. So 1 plus 5 by 3, and here you have 3 minus 8 by 3. So this will be P mm, This is 3 minus 4. I made any mistake putting the values? mx2 plus nx1. AQ, yes, this is okay. It's 2. So I think this is okay. Then this is 6 by 3, and this is 2 minus 8 is minus 6 by 3. So this becomes P2 minus 2. So we've got the coordinates of P as 2 minus 2. But what are the coordinates of P given here? Coordinates of P given here are P comma minus 2. So therefore, P comma minus 2 must be equal to 2 comma minus 2. That means the value of P is 2. Okay. Now we want to calculate the value of Q. Okay. So this time what I'll do here is, so now what I'll do here is I'll calculate AQ is to QB, that is this length which is becomes 2K is to this length which is K. So here for the second part you have here AQ is K plus K, which is 2K. I'm talking about AQ, this length 2K. And what is QB? QB is K. QB is K. So therefore AQ is to QB. Well, let me write in fraction form first. AQ by QB is equal to 2K by K, which is equal to 2. That means if I write it in ratio form, AQ is to QB must be equal to 2 is to 1. So I've got this ratio. So Q divides AB in the ratio 2 is to 1. Therefore Q divides AB in the ratio 2 is to 1. Okay, and what are the coordinates of A here? Coordinates of A here are given to be 3 minus 4. Coordinates of B, the extreme points, here are given to be 1, 2. And the ratio here is AQ is to QB is equal to 2 is to 1. So that means which direction should I take? So this one should be my x1, y1. This should be my x2, y2. And this ratio, here I have two parts. This is my two parts. M is equal to two parts. And here I have n equal to one part. Okay. So I know the values of mn, x1, y1, x2, y2. So we'll put therefore coordinates of q. So this one was my x1, y1. And this one was my x2, y2. And this is my m, this is my n. So therefore coordinates of q, mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n. Put the values here. Q 2 into 1 plus 1 into 3 divided by 2 plus 1. And you have 2 m y2, which is 2 plus n y1 is minus 4 divided by 2 plus 1. Okay, we simplify this. to get the value of Q as, I think I'll continue this tomorrow. Okay, because